Hey guys, welcome back. Today we're looking at 5.4 log functions. So the thing to remember about logs, they're just the inverse of exponential functions. Just like multiplication and division are inverses and addition and subtraction, we can rewrite an exponential as a log and we can rewrite a log as an exponential. So like if I said that 6 times 2 is 12, I can rewrite that as a division problem, like 12 divided by 6 is 2. So they're related in that they're inverses because we can use the same numbers to rewrite the different to rewrite it in a different form. All right, so let's kind of talk about what's going on here. So let me erase that stuff that I just wrote. I'm going to talk about here. So y is going to be the exponent, a is going to be the base, and x is going to be the value. All right, so if we think about our exponential functions, it has the same thing, right? The base is the a, the y is the exponent, and the x is the value. So the reason why we work with logs, right, is because it's going to be, our y is going to give us the exponent. It tells us what the exponent on our a should be so that we get the x value. All right, so let's kind of work through this. And the more you do it, the easier it gets and the more you'll understand how it works. But let's change this to log. So we're going to say log. What is our base? Well, our base is 4. Our value is 16. And then it's always equal to the exponent in log form, right? So our exponent is 2. So we say log base 4 of 16 is equal to 2. Okay, so let's look at the next one. E to the x equals 4.6. Okay, so the thing to remember is that e, when we do our log base e, rather than say log base e, what they use is ln. And it's weird because ln stands for natural logarithm, but it's ln, not nl. And I had to go research that back in the day because it didn't make sense, but it turns out that's like French. So it's logarithm natural. That's why it's used ln. Okay, so anyways, rather than say log base e, we're going to say ln because our base e. Our value is 4.6 and our exponent is x. Okay, on the next one, it's in log base form. So log base 3, 1/9 equals -2. It's asking us to change to exponential. So we start with our base. Our base is 3. Our exponent is -2. Our value is 1/9. Okay, just like we did above, we know that ln is base e. So for number 2, we're going to say e to the exponent. Our exponent is 4. And then that's going to be equal to our value, which is x. Okay, so let's simplify here. It's going to kind of get into the properties of logs, but this is pretty easy. Let's convert it to exponential form first. So our base is 8. Well, actually, let's not put that so close to the equal sign because they're not technically equal. So our base is 8. We don't know what our exponent is, right? It says log base 8 of 8 equals, we don't know. But our value is also 8. Okay, so it's asking us 8 to the what power is 8? Well, that's going to be equal to 1. Okay, same thing here. Our base is 1/3. We don't know what our exponent is. And our value is 9. Okay, so the tricky thing here is we know that 3 squared is 9, right? But it's 1/3. So what we have to do is we need to reciprocate. So it's going to be a negative. Right, our exponent is a negative. That means it's reciprocal. And then 3 squared is 9. So -2 is going to be our exponent here. Okay, so again, because it's in fraction form and we want it to just be 3, we use the negative for our exponent, which reciprocates it, and then we can just square it. Okay, last one. Square root 3 is our base. We don't know what our power is, but our value is 9. So I know square root of 3 times square root of 3 is 3. And then square root of 3 times square root of 3 again is another 3, and those will be 9. So this is 3. This is another 3, and then when we multiply those, it'll be 9. So the exponent's got to be 4. Okay, that's it for today. Good job. Let me know if you have any questions, and we can cover them next time. I'll see you then.